All right, we're going to talk about section 9.5, which is talking about volume and surface area. And we're going to be talking about space of figures, volume and surface area of space figures. So what that means is basically spatial figures are figures that have 3 dimensions to them. And we're going to be talking about how to find the volume and the surface area of those spaces and what that means. So space figures, like I just said, take up 3 dimensions of space. So a pyramid is an example of a space figure, a cone, a cylinder, a fish tank, or a rectangular prism are all examples. So one important group of those are called the polyhedra, and these are shapes that are only made up of polygons. So some of the different shapes that you might see are a tetrahedron, which are made up of 4 equilateral triangles, and there's pictures of these on the next slide. A hexahedron, which is also known as a cube. An octahedron, which is made up of groups of 4 regular triangles, and regular means that all the sides and all the angles are the same. A dodecahedron, which is made up of groups of 3 regular pentagons. And then isosahedron, which is made up of 5 regular triangles. So if you look at this, here you have a tetrahedron, and you'll notice that you have 4 equilateral triangles, the 3 sides and the bottom. A hexahedron, which is a cube. Well, didn't do that on me last time. Okay, an octahedron, which you'll notice you've got the 4 equilateral triangles on the top and 4 equilateral triangles on the bottom. The dodecahedron, which is made up of pentagons, and the isosahedrons, which are made up of, again, the triangles. So what we're looking at with this next slide are some pyramids and prisms, and the difference between pyramids and prisms. And you'll notice that with a pyramid, all of the sides are triangles, and then they have a polygon for a base. So this is a very important difference. With a pyramid, the triangles are all sides, and the base is a polygon. Now, a polygon could be a side. It could also be a square or a rectangle or a trapezoid or any other shape. So if you think about the Egyptian pyramids, again, think about those. They are typically square bases and then the triangles for the sides. With a pyramid, there is always one base. And again, think about a pyramid that you're familiar with. Prisms, on the other hand, have 2 faces in their parallel planes, and these are congruent polygons, so there are 2 bases. So an example of a prism would be a fish tank, where you have a top and a bottom on the fish tank, a tissue box, which is a rectangular prism, anything that has, it's a solid shape that has a top and a bottom to it. Okay, so what we have here on this slide, we have some examples of some pyramids, and you'll notice the first pyramid is a square pyramid because the base of the pyramid is square. So this one was a square pyramid, and it looks like this second one is a pentagonal pyramid because the bases are pentagons. And on the prisms, you have a triangular prism. And on this one, again, we have a pentagonal prism. So the difference between the 2 of them, they both have triangles or squares for bases, but the difference is that the sides on the pyramids are triangular shaped and the sides on the prisms are rectangular shaped. And then we have the cones and the cylinders, and a cone is a pyramid basically that has a circle for a base. And a cylinder is a prism that has circles as bases. The last shape you see there is a torus, which is just a donut, if you want to think of that. Okay, so volume, when we're measuring volume, we're trying to measure the capacity, how much it can hold inside. And we always measure volume as cubic units because we're always going to be multiplying by 3. Surface area is a little bit harder to explain, but surface area is if you could imagine that you took off the skin of the shape and you peeled it and laid it flat. That's what we were looking at with surface areas. What would the exterior of the shape be? A good example that I like to look at here is if you think about a Pringles can. The cardboard of the Pringles can, including the top and the bottom, would be the surface area. So how much cardboard does the can require? Surface area, again, you could think about a tissue box. How much cardboard is needed to make the tissue box? That would be the surface area. Whereas the volume would represent how many tissues can you put into the box. So here are some of the different shapes we're going to look at. The first one is a rectangular prism. Again, you've got your rectangles for the sides, and your bases are squares or rectangles. It doesn't really matter. And we're finding the volume. And to find the volume, you take the length times the width times the height. To find the surface area, what you have to imagine is that we have a top and a bottom on this shape, and we have two of them. We have one top and one bottom, and they're the same size. We have a front and a back that are the same size, and we have a left and a right that are the same size. So we're taking all three rectangular pieces and adding them together and then doubling them. So here we have a problem. Find the volume and the surface area of the box below. So we'll start with the volume. It's a little bit easier. So volume equals, and one of the important things, it really does not matter which piece is the length, which is the width, and which is the height. And so what I just strongly recommend you do, especially for this formula, is just to label the three pieces, length, width, and height. And then you're going to substitute in. Volume is length times width times height, so it's going to be 7 times 2 times 3. So we're going to end up with 42 inches cubed is our volume. And here's the reason why we do surface area, or here's why I recommend that. To find the surface area, the formula is 2 times length times width. So we're going to do 2 times 7 times 2 plus, and then it's 2 times length times height. So 2 times 7 times 3, and then it's 2 times height times width, so 2 times 3 times 6. I'm sorry, 2 times 3 times 2. And so if we do our mathematics on that, we're going to end up with 28 plus 42 plus 12, and all of that added together is 82, and it's inches squared. Okay, so if you can think about, they've given you two different formulas here, but you can also think about the cube as being a rectangular solid, and you could call this the length, this the width, and this the height. And you could use the same formula, length times width times height, or you could use the 2 times L times W plus 2 times L times H plus 2 times H times W. But they did give you another formula, and considering that you are able to use your notes, there's nothing wrong with knowing these two formulas. So S cubed means basically length times width times height. You're multiplying the three sides together. And surface area would be 6 times the side squared. In other words, you're finding the area of this face of the square, and then knowing that all the sides are the same, you're going to multiply them all together and multiply by 6. So find the volume and surface area of the cube. So since they told you it was a cube, we know that all the sides, the length, the width, and the height, they're all 5. So volume is going to equal 5 cubed, which is 125 feet cubed, or cubic feet. And surface area is equal to 6 times 5 squared, which is 6 times 25, which is 150 feet squared. All right, so here's a couple other formulas. We're talking about a cylinder in this case. When they talk about a right cylinder, that just simply means that it's a straight up and down can, that there's no slant to the sides. So R again is the radius of the circle base. H is the height of the can, or the height of the cylinder. And we're just going to use our formulas and substitute it in. So the first formula for volume is pi r squared h. And the formula for surface area is 2 pi r h plus 2 pi r squared. So let's look at this. Find the volume and the surface area of this cylinder. So volume equals pi r squared h. Oops. R is 2 in this example, and h is 10. So you're going to do pi times 2 squared times 10. So you're going to end up with 40 pi. And if I told you, remember, to leave your answer in terms of pi, you would stop there. Or if you go one more step, you'd get 125.6 meters squared, or excuse me, meters cubed. Okay, to find surface area formula is 2 pi RH plus 2 pi r squared. And again, all I'm going to do is take this information and substitute in. So 2 pi, the radius is 2, the height is 10. Substitute in this information, you get 2 pi, 2 squared. So if we work all this out, we're going to end up with 4 times 10, which is 40 pi. Over here, we're going to end up with 4 times 2, which is 8 pi. So this would simplify to 48 pi. Or if we go one more step, it would be 150.72 meters squared. All right, here we have a sphere, and a sphere is basically a basketball if you want to think of it that way. Again, this time we're looking at r cubed, r to the third power. So the volume would be 4/3 pi r cubed, and the surface area would be 4 pi r squared. So r in this situation is 9, so the volume is 4/3 pi 9 cubed. Now to do this on your calculator, what I recommend doing is do the 4 divided by 3 times pi, and there should be a pi button or a 3.14 button on your calculator, or you type 3.14, times 9, and there's usually a caret button on your calculator. A caret looks like that, raised to the third power. So if we work this out, 4/3 times pi times r cubed, you're going to get 972 pi, which is equivalent to 3052.08 inches cubed. To find the surface area, you're going to do pi times r, I'm sorry, I forgot the 4. It's 4 pi r squared. So you're going to have 4 times pi times 9 squared. So you're going to end up with 324 pi. Which is approximately 1,017.36 inches squared. All right, so now our formulas are getting a little bit more complicated. The volume formula is not too complicated. 1/3 pi r squared h. R again is your radius and h is your height. We're talking about a cone here. For the surface area, we're doing pi r And then we've got to calculate this value here, pi r squared, square root of square root of r squared plus h squared. If you notice what you're doing here, r and h form a right triangle. So you're doing Pythagorean theorem and you're figuring out the value of this side over here. And this side is what we call the slant height. Now what we're going to do with this part of the problem is figure out the slant height, and then we're going to use that in our formula. So it looks a little bit more complicated, and we just have to do our formulas in a couple different steps. So let's do a problem here. Here we have the volume. We're going to start with that one because it's the easier one. So volume equals 1/3 pi r squared h. Notice that the formula is the exact same formula as the cylinder formula, except it has the 1/3 in front. So that tells you that the volume of a cone is 1/3 the volume of a cylinder. If we continue on with that formula, we're going to get 12 pi, which is approximately equal to 37.68 meters cubed. Okay, so now to find the surface area, we're doing pi times r, which is 3, times the square root of 3 squared plus 4 squared plus pi times r squared, which is 3 squared. So we really need to do this part of the problem first. So 3 squared plus 4 squared is 9 plus 16, which is 25. And the square root of 25 is 5. So now what we have in our problem is pi times 3 times 5 plus pi times 9. And if we work all this out, we end up with 24 pi, which is approximately equal to 75.36 meters squared. All right, so here we have our last shape. We have a pyramid, and to find the surface area and volume of a pyramid, again, the volume of a pyramid is just simply 1/3 big B times H. Now here is the very, very important part. Big B is the area of the base. It is a big B, not a little b. So I am not telling you to take the value of the base and do something with it. I'm saying find the area of the base and do something with it. And H is the height. And then the second formula, P is the perimeter of the base. P is the perimeter of the base. H is the height of the shape. R is the best term I can give. It's not really the radius, but it's the distance from the center of the shape to the side. So I call that R. And big B is the area of the base. So here we have a problem here, and we're going to separate these into 2 steps. So to find the volume, so the volume of the pyramid is one-third big B times H. So we've got to find big B. Big B is the area of the base. The base is a rectangle that has length 6 and 3. So to find the area of that, we're going to do length times width, which is 18 centimeters squared. The height of the pyramid is 7. So now I can find the volume. Volume equals 1/3 big B times H. So the volume equals 42 centimeters cubed. as I'm looking at this, I think I've got a mistake right here. This should be 7. So hopefully y'all can correct this, please. And this should be 42. Okay, so I'm going to erase my writing so you can see better what the correction should be. And again, this correction should be this number 6, should be 7. And 36 should be 42. Okay, so now let's look at the surface area. So to find the surface area, again, our formula is right down here, 1/2 perimeter h plus r squared, the square root of that, plus b. So big B, in this example, the area of the base is a rectangle that is 8 by 3. So big B is 24. The perimeter of this rectangle is 2 times length plus 2 times width, so 2 times 8 plus 2 times 3, which is 22. So P is 22, big B is 24, R is 4. Now how did I get that? I want to know how far it is from this point right here to the edge. So all the way across would be 8, so this piece right here is half of the 8. And then the H is 7. So I'm going to plug that in here, and I get the perimeter is 22, 7 squared plus 4 squared plus big B, which is 24. So 7 squared plus 4 squared comes out to be 49 plus 16, which comes out to be 65, the square root of 65, which comes out to be about, oh, I did forget to figure that out. It comes out to be about 8.06, I think. And then plug that into the rest of our problem. So half of 22 is 11, times 8 is about 88, plus the 24 ends up to be 112.68. All right, so let's do one more. Find the volume of this pyramid. So volume equals 1/3 big B times H. Big B is a rectangle. Rectangle is 10 by 5. So big B equals 50. The H is 12. So you have 1/3 big B times H, which is going to end up to be 200 centimeters. I did forget to put that in, centimeters cubed. All right, our last one. Our shape again, the bottom of the shape is a rectangle that's 10 by 5. So big B is 50. The perimeter is 2 times 10 plus 2 times 5, which is 30. So the perimeter is 30, big B is 50, R is 5. Again, I got that because I took half of the 10. So there's my 5. And the H is 12. Plug all of this into the formula, so you get right here 144 plus 25 is 169, and the square root of 169 is 13. So I end up with my surface area being 245 centimeters squared. All right, I hope this helps. Keep in touch with me. Let me know how things are going, and let me know if you need any help with this material. Have a great week.